Okay, lesson 68 is purely just a lot of review about even and odd functions. We talked about even and odd. I don't know, did we talk about even and odd as far back as Algebra 2 or just pre-calc? So definitely in pre-calc, maybe in Algebra 2, I'm not remembering right now. But a function can be even, odd, or neither. Okay? If a function is even for all values of x, there's two different ways you can tell a function is even. One is that f of x and f of negative x are equal, or the graph of f of x is symmetric across the y-axis. This is for an even function. Does that sound a little familiar? If it's even, it's symmetric across the y-axis if you have a graph. If you're looking at functions, it's f of x equals f of negative x. Okay, odd. Remember anything about odd? An odd function is a function that for all values of x, f of negative x equals negative f of x. So that's always the one we check secondly. And then the graph of f of x is symmetric across the origin. Okay? So, we're going to look at several different ways that this symmetry can help us here. So, example 1 is the function even, odd, or neither. What are your thoughts? How do you want to figure that out?
1 and 3 checks, I'm guessing. Yeah, how can it be neither?
If it's not symmetric around anything.
That's what I was thinking. I was just confused.
Or if it's symmetric across the x-axis, because that doesn't fall into either of these categories. So, okay, guessing 1 in 3 chance is not the direction I want to go here. Prefer a more mathematical approach, which I'm waiting for. There's mathematics in guessing, but see.
We're about to take the ice test. These days. Yes, B, and C for all the answers. Not really.
We could put in one negative one. Stop.
Okay, so one option is we can look at algebra. Okay, if you don't necessarily I know an idea of what an x to the 4th graph looks like, but specifically what this one looks like, I don't know until I graph it on the calculator. So I can use algebra. If I'm using algebra, we start by finding f of negative x. So if I'm finding f of negative x, that means every place there is an x, we replace it with negative x. So x to the 4th means we're going to go negative x to the 4th. X squared, it means I'm going to go negative x to the 2nd minus 6. Yeah. What happens when you raise a negative x to an even power? Yeah. So this is going to be positive x to the 4th, positive x to the 2nd, minus 6. What do you notice here? It's the same. And so, since f of the original f of x is equal to f of negative x, what do I know about this function? It is even. Now, did you graph it, Logan?
I did.
And what's it look like?
It's a parabola that's 6 down and then another one that's upside down right next to it. Well, right below it. Well, I graphed the positive and the negative one. So, it works for.
Positive and negative one. What are you talking
I
about?
graphed the positive equation and the negative equation.
But the negative equation is the same. Did you put negatives here without parentheses? I'm so confused.
No, do it again. Let's see what happens. Don't look at me like that, Nathan. You didn't use that.
Okay, well, here's what I would say. By graphing only the original equation, you will see that it appears to be symmetric across the y-axis. because it's symmetric across the y-axis, there's no other graphing you need to do there. We know it is even. Now, the negative one, you don't have it plugged in right. Did you use parentheses around your negative x to each power? So.
I'm sorry that I'm not good enough for you.
So if I do x to the fourth, what is it? Plus x squared minus 6. There's 1.
Alright, so is that what you did?
That's the original. Negative x
Yes.
raised to the fourth
So I've done twice now.
plus negative x, crud, redo, negative x raised to the fourth
What the heck now, friend?
plus, so I don't need to come back there and check it.
No, I did it a third time exactly the same. And Trevor looked at it this time and fixed it.
Okay, so the point is we have, it's a fourth degree equation. It kind of looks a lot like a parabola. It's centered on the y-axis. It's symmetric across the y-axis, so it is even. Okay. If you're going to use the graph, though, the idea of using a graph is just use one and see, does it, is it symmetric across the y? Okay. Next one. Is f of x equals x cubed minus x even, odd, or neither? So what do I start off doing? Okay, we're doing this algebra, plug in negative x. So I'm going to have negative x to the third minus x. What is negative x to the third? Negative x to the third. Yeah, valid point. Okay, that should say, I would have realized there's an issue later when things weren't matching up the way they're supposed to. You can't read that now, but it does say minus negative x, which makes this plus x. So what do I do at this exact moment?
Well, it's not even.
Okay, it's not even. Okay, so there we go. We've improved our probability of guessing the correct answer at this point. So next we need to find negative f of x. Do you remember how to do negative f of x?
Yeah.
Just multiply the entire equation by a negative. So take a negative and distribute it. Take a negative and distribute it. And we're going to have negative x cubed plus x. What do you notice? Those boys are the same. There you go. And so that makes this odd. Did anyone graph the original?
No. Never.
Well, let me show you at least a sketch of the original. If you were to graph the original, it would look something like that. Because I want you to physically see what does it mean to be symmetric around the origin. Okay, so symmetric around the origin, I like to think of it as kind of like a double reflection, where something reflects over the y, but then it also has to reflect over the x. So it reflects over both axes. You end up in the diagonal quadrant. You can also kind of think of it, there's a rotation there. If you take like the left half of this graph and rotate it onto the right half of the graph, you can think of that too. Okay? So that's kind of what the visual looks like there. Okay. Example 3. Evaluate the following. So shall we evaluate? Let's evaluate. We're going to evaluate. Okay. The integral of x cubed minus x from negative 1.5 to 1.5. What do I do? Okay, what's the integral of x to the third? 1/4 x to the fourth minus the integral of x? 1/2 x squared. Evaluated from negative 1.5 to positive 1.5?
So that's the equation. It's the equation from above. I feel like we have to make two integrals.
I didn't even pay attention to the fact it's the equation from above. Okay, well, here's the deal. The directions say to evaluate. So we want to find the value of this integral. Does it say anything about area? No. Okay. We are just evaluating. So we are finding what does this integral equal. Okay. We're not putting the thought into, do we think about what's positive, what's negative? Do we break this up into various integrals? Because that's not what they asked. Confusing, I know. Which, well, we'll talk about here in a moment because I was going to talk about it at the end. But if you take into the account that this is an odd function, it does mean something about what my answer is pretty much guaranteed to be. Have you guys figured out what my answer is going to be here? Nathan's got it. If you're doing this graph here, and it's from negative 1.5, which is somewhere over here, to positive 1.5, which is somewhere over there. Well, integral does the area under the curve, right? So, what are your pieces of area under the curve? Sorry. There we go. Better? Okay. So if you look at this, we've got this mountain and this valley, yes? And then what other places do we have to consider if it's the area between the graph and the x-axis? Triangle? Triangle. Now, not drawn perfectly, but what's going to happen? They're all going to cancel each other out, right? We've got positive and negative of each type, and so this is going to equal 0. And the trait here to realize is because it is an odd function, it will equal 0. Now, again, if they asked us to find the area, we would have to consider this differently. Okay? Bless you.
Thank you.
Now, officially, if you plug them in, and I wasn't going to do all the math out because we'll be able to see pretty quickly, plug in positive 1.5. So it's 1.5 to the fourth divided by 4 minus 1.5 to the second divided by 2. And then minus, and then next time we plug in negative 1.5, negative 1.5 to the fourth divided by 4 minus negative 1.5 to the second divided by 2. Well, without actually doing the math out and messing with those 1.5s, what can you tell? They're going to cancel each other out, aren't they? Okay. So yeah, do pay attention. Or they want you to find area, they just want you to evaluate what the integral equals. Okay. Questions there? Example 4 then? Is g of x even, odd, or neither? Does that say x cubed? My line kind of went into it. Yeah. I had to look at my original or my other. Okay, so what do we start with? G of negative x. So negative x to the third minus negative x, I'll get it this time, minus 4. Can't let Trevor save me too much in one day here.
Things that probably wouldn't have caught it
Well, you caught it today. I don't know. My math day has been rough today for whatever. No excuses. It just has been. You know, you have good days and bad days. It's not been a good math day. No excuses, just hasn't been. Okay. What's this become? Negative x cubed plus x minus 4. So what do we know right now? It's not even. My signs don't match up. So now we're going to find negative g of x. So remember, you are multiplying each term by a negative. And so we multiply each term by a negative, it becomes negative x cubed plus x plus 4. What do we know now? Okay, it can't be odd because none of the three of these match up. They all are off by a sign. So if it's not even and it's not odd, we are to neither.
Remember the third one that's symmetric across the x-axis?
Nope.
No,
Yep.
I didn't know if there was like a mathematical term.
There is not.
There is.
Okay. Y equals negative 3 tangent of 2 pi x. We've got to...
Symmetric anyway. I mean, on any axis.
Are you talking about tangent, isn't?
The neither isn't, because it's just translated down 4 units.
Right. Yeah, and neither, I mean, it could, I mean, something that is symmetric across the x-axis would fall into the neither category, though. So, okay. Oh, is it there? Is that the page I need to find? Yes, there's the spot it is. Okay. Just lost this page. So, how do we determine if this is even, odd, or neither? He's going to graph it. I'm not going to graph it. You can, but I'm going to plug in my values, right? So the first time, you plug in negative x, yes? So negative 3 tangent of 2 pi times negative x. Well, what is 2 pi times negative x? Negative 2 pi x. So this is equivalent to saying negative 3 tangent of negative 2 pi x. Now, this is what I was flipping through my notes to figure out where to tell you when you need to remember. We have some trig identities from last year that tell us when there is a negative inside a tangent, what does that convert to when you take that negative outside? It's a negative, right? So it's our even odd functions from last year. The fact that tangent of negative x is equivalent to negative tangent of x. That is the identity that we learned last year, and that's the identity you have to put into effect here. And you had, after lesson 4, you had a page of helpful pre-calc stuff. That's where you can find this, okay? And it might be somewhere else, but that's a place you can find it. So, if you take that negative alpha the 2 pi x, what does this become? Positive 3 tangent of 2 pi x. Okay? So, what does that tell me right now? This is not even. Okay? Try the next one then. Next time, what do I do? Yeah. So it's the negative times negative 3 tangent of 2 pi x. So negative times that negative is going to make this positive 3 tangent of 2 pi x. Well, what's that tell me? Yeah, these two end up being equal. So this is an odd function. Now, that makes sense. I would expect a tangent function to be odd. Okay, I would expect a tangent function to be odd because that's exactly what this is saying. Tangent of negative x is equal to negative tangent x. Okay. Okay. Example 6a. Even, odd, or neither. Okay. About f of x equals e to the x. First thing we're going to try is f of negative x, which gives me e to the negative x. The next thing I'm going to try is negative f of x, which gives me negative e to the x. So what do I know? It's going to be neither. And think about it. Can you visualize what e to the x curve looks like? It's that exponential curve, right? It runs along the x-axis and then goes exponentially up after it crosses through 0, 1. So yeah, it's neither. Now, e to the negative x squared. Okay, I have a little bit harder time visualizing that one. So what do? F of negative x is e to the negative of negative x quantity squared. Well, what's negative x quantity squared? X squared, but then we have the negative in front of it, so it's back to negative x squared, which that tells me this is even.
Since the parentheses were in that original problem, you always include them with like that?
Anytime I'm putting a negative value and then raising it to parentheses, so like here we're inputting a negative x, I always include parentheses. Because it's going to be the negative raised to that power. Because you raise it to the power before you multiply it by the negative out front. Does that answer the question? And it kind of comes down to order of operations. Okay. One last one. I think it's one last one, right? Yeah. Okay. G of x, x squared plus cosine x all over sine x, even, odd, or neither. So, g of negative x. This is where I'm going to use parentheses. Negative x raised to the second plus cosine of negative x all over sine of negative x. Okay, what do you have to remember to do this problem? Yeah. Cosine of negative x and sine of negative x. What do you remember? Okay. Cosine stays positive, sine becomes negative sine x. And if you can visualize the graph of cosine. The graph of cosine is the one that starts up at 0, 1, yes? So think about that. The graph of cosine is symmetric across the y-axis. If it's symmetric across the y-axis, it's even. And so cosine of negative x is going to equal a positive cosine x. Sine is symmetric about the origin. It's odd, so sine of negative x equals negative sine x. Okay? So, let's clean this up. Negative x raised to the second becomes x to the second. Cosine of negative x is plus cosine x. Sine of negative x? Negative sine x. Okay, do we match the original? No. We are off by a sign. So now we need to try negative g of x, which means you take a negative and you multiply it by the function. How do I multiply it by a fraction? How do you multiply a negative by a fraction?
Put a negative out front of the fraction.
Okay. You can put a negative outside of the fraction bar, out front of the fraction bar if you keep it directly in front of the fraction bar. Or you can multiply the numerator by a negative, or multiply the denominator by a negative. Okay? Generally, we think of, if you don't put it just out in front of the fraction bar, it either goes with the numerator or with the denominator. If I multiply numerator and denominator by -1, well, a negative and over a negative is a positive. So I've just multiplied by a positive. Multiply it by one or the other. Well, what's going to happen here? Yeah, if you multiply it by the denominator, it looks identical, doesn't it? And so this is what? Odd. Okay. Okay. Let's check some homework. I'm trying to think what all we still have to do to catch up in this class. You could have started erasing pages.
No, thank you. How many chapters do you have left this year?
You talking about in here?
Yeah.
We go to 104, but we start. The farther we get along in this book, the more we skip. 104 is long. I don't know that will quite make it. Do you only use it for this homework?
Well, this section, yeah, but I have other sections I can't use.
Okay.
Yeah,
Or did it move
I got out of my house.
I didn't know what to do about it.
Before the first semester.
Okay, guys. 60, not 68. Dang it.
Whoa, can you do that up there?
You guys are too slow.
I didn't even think about it until there was said that.
You gotta catch me on my mistakes quicker than I catch myself if you wanna help there.
We are taking
I'm already ripping my paper out of the, I was working towards it.
Okay.
Steady, and then you hurry up and jump.
67 is what we're checking today. Oh my goodness.
Sneaky boy.
This week is.
Did you get number 1? I actually did. I had to grade for second set of reading. I drew a picture, and then I started thinking about how to do it, and I could not make my brain work. Like, I was surprised I got it, because it's a bunch of, like, tricks that the guy did, and it's really weird for the calculator. So I'm surprised I got it right, but I did.
Did you have to draw the picture or did they give you the picture?
Yeah, they're all in.
Okay, so if you can get the picture drawn, looks like we have a flagpole and whatever else going on there. And then we have the angle. Okay? And then what you need to look at is the relationship between that angle and those two sides. Well, you've got a right triangle, and that's a tangent relationship. So, Katoa, what my pre-cal is learning right now, or learned yesterday, okay, tangent is opposite over adjacent. So the tangent of theta is equal to h over 5. And then from there, they went ahead and solved for h. So multiply by 5. H is 5 tangent theta. And then they differentiated. Okay, the derivative of h is just 1. Whatever we're doing in this problem is with respect to time, so do a dh dt. Derivative of 5 tangent, well, the derivative of tangent is secant squared. So 5 secant squared theta and then d theta dt. Okay, from there, you must be solving for, you must be finding the rate of change of the angle because you're finding d theta dt. And so you do the change of the height is 1, 5, and then you can find secant because secant squared. Secant would be the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then hypotenuse over adjacent, which they must give you. I really should have just looked at this problem, shouldn't I? I'm trying to, think backwards here. They must have told you at some point the height of the flagpole was 12.
Yeah,
I think it's the height of the flag.
The flag is at 12.
Okay. So when the flag is at 12 is when you're trying to find your answer. Yeah. G is standing 5 meters away from the base of the flagpole. Flag is being raised at the rate of 1 meter per second, so that's the change in height. Find the rate of change of the angle of elevation of G's feet to the flag at the instant the flag is 12 meters above the ground. So you don't ever see the 12 in here, but you would have had to plug the 12 onto the triangle, right? And then it would have been Pythagorean theorem. 5, 12, and Pythagorean theorem will tell you that's 13. Or something that you guys don't learn anymore is Pythagorean triples. I know certain Pythagorean triples, and that's one of them I know. So, like 3, 4, 5 is a Pythagorean triple. 5, 12, 13 is a Pythagorean. Like, those are sets of numbers that make a right triangle. So it's not. I don't know where it would be taught. Maybe it'd be taught in geometry. I don't know. It's something I remember learning at one point. There's some others out there, and if 3, 4, 5 works, well then so does 6, 8, 10, and those kind of multiples. I'm trying to think. I don't know. There's others out there, but.
No.
Okay, there is 2 and 3. You gotta be careful how you treat the notes if you want it to last.
Somehow mine always ends up coming unspiraled at the top for no reason.
Oh, yeah.
It must be how you treat it somehow.
I don't do anything to
So
it.
see, mine doesn't do it. I have to rewind through the holes every day.
How do you do it? I tried so
You
hard.
just spin it. And you gotta line it up with it.
Well, and I think what's happening then is because if you don't, at the beginning, there's a little piece that prevents it from unspiraling.
Right.
So once that piece breaks off,
Yeah.
you're doomed.
It happens like a couple of months in for me, like every single time I've got
It might be kind of fun over there. I don't know. You're just trying to stop.
But this notebook is actually really good. No, yeah, it has a.
The problem was it came
Did you guys check 2 and 3?
plastic off.
Yeah.
The plastic was like pulling out each time I grabbed it and it started ripping off the plastic.
I got one.
For the paper for you to
5 hours later.
I can do this.
Oh, I guess there's a 3B.
Sometimes. Those are the alternate time certain days.
There's 3B and there's 7. Did you guys catch on 7? It sounds like it looks like it told you to write an integral, but you didn't have to solve it.
There's a couple of set of right ones.
Yeah, when they do that, watch out for it, 'cause they tend to get in a habit when they do that.
I don't think I solved it anyway.
Okay.
I just wrote the entire thing over
Okay.
-2, so I think it's a problem.
Like -1y plus 3.
I have y minus
You said negative 2. Yes, that'd be equivalent then. I missed the fact you said negative. That's where my brain did not keep up.
He legit looks like a 13 before I rewrote it. So how did I get 13? Without
No! Oh, that means I'm still recording.
Wait, that means if I go back and watch the video, I can see 68 answers.
Yes, you can.
yeah.
Otherwise, my screensaver wouldn't have gone